So now let's see how to design our first neural network, right? What we have done so far is something like we have X and then we have Y. Very, 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 very easy, right? And then I said we have answers and then we have data and then we are looking for the rules, right? And then once we are able to get the rules and stuff like that, we can now just give it data and then it will predict for us. And then that prediction is what is known as inference, right? So now this is a code to design our first neural network. So this code will be able to design our first neural network. It will get some training data and then it will train our neural network. And then it will be able to make predictions for us. This how many lines? One, two, three, four, five, six. 6 lines of code can do all of that. Understood? Just this 6 lines of code, and then all the codes always follow this sequence. So that's what makes it easy. So because we are using, I said the last time we are using a library called TensorFlow. And then that TensorFlow library makes everything easy for us. We just have to call some function within the TensorFlow flow library and then it will do the rest for us. You don't have to think a lot. Right? You use the what? Yeah, all of them. The matplotlib is part of it. The matplotlib, the numpy. So once you are doing it, you have to import all those functions. You'll see very soon. So this is just how it looks like, just 6 lines of code. But each line of code is so integrated, right? Each line of code means a lot, right? For instance, the first line of code, model is supposed to keras the sequential, then keras the layers, then unit one. It means a lot, right? So once you understand what each word means, then everything becomes easier because all the machine learning stuff follows a form like this, right? So what are we doing? We want to design a model. So we just give it a name, model, right? The keras is the library we are using. So the keras. So once you use keras dot something, it means that we have the first name is the library. The dot is a function within the library we are calling, right? So keras dot sequential, then into bracket keras dot layers. It means that within the keras function we are calling layers, and then within the layers function we are calling another function called dense, and then we give it some values. Units is equal to 1. So all of them means something. But let's see what just the first line of code, right? Let's see what it means, right? So if we take this is how a neural network looks like normally. I think I've explained this before that we have our input layer. We always have an input layer, right? With right input layer. Then we have what? The hidden layer. And then we always have the what? The output layer, right? Now this just one circle here is the neuron. Very, very important. Just one circle is a neuron. So if we are designing a neuron with just one input and one output, we use only one neuron, right? So just that circle is the neuron, right? Now we from this neuron or from this neural network, uh, let's look at here, right? This neuron is connected to all the neurons that come after it, right? This neuron is connected to all of them. This one is connected to all of them, right? This is what we call a dense neural network. So this is a dense neural network. All the interconnections are connected to each other. Have you seen it? So we have a neuron. So we have seen that if we are done a network with just one neuron, it will just be one neuron with input and output. Then we say that this is dense because all here once you check in between the layers, the interconnections are all connected to each other. We check in between them, they are all connected to each other, right? Right? Yes. Now, this we have input hidden and then what? Output, right? And then this neural network is sequential. Why? Because data always flows from here to here. It can't flow like this, right? Once we have our input layer, from our input layer, we go to hidden layer. From the hidden layer, we go to the what? The output layer. So this network is sequential. We have different type of network, but this one is sequential, right? So here you have learned a lot of information from this one, right? So if you pay attention, last week I talked about the neuron, just one neuron. I wrote something like if you have something like this, each input has what is called the weight. I mentioned it, right? So we have W1, W2, W2. If you have three inputs, you have W1, W2, W3, and then within each neuron has what is called the bias, right? So we have the inputs in one, in two, in three, and then we have our output, right? Let's say one, right? And then I gave a formula like y is equals to what? W1 times y is equals to in 1 times W1 plus in 2 times W2, right? Yes, sir. Going. It depends on the number of neurons which we have, and then plus all of them will be added to the bias, right? Yes, and then I said that we pass this entire thing through a function, right? Called what? I said after we have done all these calculations here, we pass it through a function, f, and then that function is called the activation function. The activation function. Activation function. Right? Okay. So now with all this information, let's go back to our code. So we have, as I said, we have input, hidden, output layers, and then we have layers, right? And then we have this one being sequential, and I explain why it's sequential. So let's go back to our code. So let's take our first line of code, right? So what we are doing is we want to we have our x values. What we are doing first of all, we have our x values, right? The x values, and then we have the y values. Some x matches some y values. So this kind of architecture will have only one neuron because we have x, and then we are feeding the x through the neuron, and then we are getting just one value, y. So x is the input, y is the output, right? So it means that this one will have a weight, only one weight, because it's just one. And then this neuron will have a bias, B, right? So what we are doing is we are doing y is equals to x times w, right, plus b. This is all we are doing. Once we design something like this, x times w, x times w plus b equals to y. I've already explained that. Sir, the first one, is he N or I? Here, I said in one, in two, in three. Input one, yes, the short form. So this is what we're doing. The bias, we have weight and bias. The weight and bias are the parameters, right? So that's what we are doing. So now let's look at the first line of code. So we said keras.sequential. So it means that this network is sequential. So that's why we put it there, sequential. And then to bracket keras.layers. We are using layers. So we need to call that function layers. And then dot dense. I said dense is when all the neurons are connected together. Data is just one, but all the neurons are connected together in just one. So we have to use dense, right? And then into brackets, unit is 1. The unit is the number of neurons we have within that layer. Have you seen it? So unit is equal to 1. And then the shape is the input. The input is just one input. So that one too is, have you seen the 1? Understood? So it means that once we do this, keras.layer, so that one means that we have only one layer. And then we do dense, all the layers, all the interconnections are connected together within that layer. The unit indicates the number of neurons. So if the neurons were, we are using 3 neurons, it will be 3 here, right? And then we have the inputs. The input is just 1. That's what we have there. You see how easy that is? Then after that, so there is the 1 neuron, 1 layer, and then the input is just 1, right? So this is what we have done. Just what I do here. So our next is we have to compile our model. So we use, so you see that we define our model as model. We define it as model. So all that, so anytime we want to call the model, we have to use the name model dot something model, and then it will refer to what we created. And that's so we use model dot compile, and then we use the optimizer. You saw that I said you make a guess, you find your accuracy, and then you actually optimize. So the optimizer here, we are using SGD, right? And then we are using the loss. You see that our loss is the same thing, mean squared error. So it's going to do what we did previously, but it will do it for us automatically, right? So after that, we define our y and then our x and y's, the x values and then the y values, right? And here we use a library called the numpy. I think I explained this that the numpys are used for arrays. So once we use np.array, then you can define your values as arrays. And then here is type float. It's a floating point. They are floating point numbers because we have 1 point something, right? So we have our x, we have our y. Then we now call again model.fit. When you see fit, model.fit, it means that let's start training, right? And then you see that once you use model.fit, we have x, the x values, the y values, and then we have epochs of what? 500. So it means that we are training for what? 500 times. As easy as that. Then after that, we do model.predict. We have finished training. So let's now predict a value outside the values we use. These are here, our x were what? Minus 1, 0, 1, and whatever. But after that, we can now use any number at all we want. We can predict any number at all we want at the x. So we do model.predict, and then we give it 10 and see how accurate it is or how close it is, how close the value will be to our y. Understood?
Yes,
So,
but the initially the unit that you gave was 1.
yeah.
So in that case, after training it, before it will, you can just maybe try another number or
What do you mean by that?
I thought maybe
Hmm.
as you, the model, the unit would just include the unit 1, maybe.
Yeah, because we are doing because this is what we are doing, right? We're trying to do the one I said y is equals to p x plus b. We are trying to model that one using the machine learning. At first, we were doing it on our own, right? Right now, we want to use machine learning actually, the TensorFlow library to run that and see how it works. That's what we are doing now. So that's why we use only one neuron. But if you're designing on your own, it will be completely different. Understood?
So when it comes to the model,
Yeah, yeah.
are you the one who are going
Yeah,
to,
you are the one.
you are going,
It is one model, yeah.
so it's like you are configuration, doing some
Yeah,
configuration.
yeah. So you need to know the number of neurons to use. You need to know the number of how many layers do I want. That is entirely your choice. So the number of layers I want. Do I want 3 layers or 4 layers?
But
We,
say, if you should just mix it up, like the model predicts against the model fix.
mess it up.
What, like, let's say you type the model predict before you
Oh
type
no,
the model fix.
it's a sequence. It has to follow. a sequence. You have to first of all give it some data before you train it. The model that fit means that train my network. After it's trained, then I now predict. So if you don't train a network, let's say you just define your model, you compile it, you give some values and say model dot predict. It will use some initial values already. It hasn't learned anything. As I said, before it learns, it initializes the parameters, the WMB. And so it means that without training, it will just give you a value, right? So probably you will see it very soon. You will see it very soon.
You need to do more training on this.
Oh yeah, yeah, yeah. So this one you
Because
must run it.
if you should just mix one
Oh yeah, yeah, yeah.
and line,
Yeah, you're in trouble with that one. That one is true.
So we said this one,
Mm.
the model fit was supposed to train it for 500 times.
Yeah, five. Yeah, 500. So and I will run one for you to see how it does it, right? Okay, so this I've explained all of this. So I think I've explained. So after that, so after we have trained, we tested it at number 10 and see what it gives us. And then that's also let's run some codes and see. Right, the code this code too is available on your on the platform. Oh, I think it's there. So here again, you just have to come to your web interface. You can close this one, and then I think it's my first neural network. So it's here. Yeah, I was running and I was getting some errors here. So our first one is we have to import the TensorFlow library. Have you seen it over there? Import TensorFlow as TF. So we import our TensorFlow library, and then we import our NumPy library for our arrays. That was really the first thing. But we can do other things. I can print my TensorFlow version. That's my choice. So if I run this code, what will happen? So it will take some time because that library is huge. TensorFlow library, so it has to import it and stuff like that. So you see that it is star, right? So it's running. Now it's done, and then it will print the TensorFlow version I'm using. I'm using 2.10.0, right? Then after that, I'll define. You see, my next cell is define my x, my y and x values. I think I already explained that, right? So I just run this, and then it will define my x and y values. Can you see?
Yes.
Okay, then my next is I can print the y values and then the shape, how it's looking like, right? So if I do this, it will print my x values. You see that minus one, minus, and then x values, and then the next line will be the y values, and then it will print the shape of it. So and then as I said, it's in the form of an array, two-dimensional array. So my array has probably 6 rows and no columns. So that's why you see 6 comma nothing. Have you seen it? And then our Y2 is just 6 rows and no columns. Like sometimes you use a two-dimensional array, so it will print the rows and columns for you. But here there are no columns, right? And that's what my next is the model itself. So you see that here the model dot sequential like whatever I said, then it has only one neuron. So I run this and then it will create the model for me, right? So now here, very, very important. I can do something like model dot summary to see how my model looks like, how many parameters my model have, right? So if I do, and then it's very, very important, model dot summary here. So now this model dot summary, this is what might come in your exam. So pay attention. So I will give you a network, right? I will like the first line model is equal to TF dot, and then I'll give you something like that, and then I'll tell you that what is the layer type. So it will be in the form of a table. So layer bracket type, right? And then the next one is what? Output shape, right? The next one is what? Parameters. So params, number of params, right? So here,
You can leave the student.
where is the zoom set? So very very important. So now if I give you something like this, and then you must now visualize that the model looks like this. The model is like this, sequential. The model is first of all sequential, right? The model has layers, but how many layers? It has only one layer because of just one line of code. Keras of layers. That is just the first layer, just one layer. Then the model is then the model unit inside here. The unit is equals to one, so it has only one neuron. So it just looks like this. That's how we do it. We have an input, we have an output, and then we have our weight and then bias. So the output shape is just none and one. The output, you see the output here is just one. That's why you see none and one there. The number of parameters is very important too. Why?
That is the weight and bias.
As easy as that. Have you seen it? So the weight and bias are the parameters, and then here it's just it's two. So that's the number of parameters, and then we have number of trainable parameters. How many parameters are we training? Only the weight and bias. So always it will be two.
So
Have you seen it? So if I do model.summary, I can get the summary of what my network looks like. Right? Okay, now so after this, I can use what is known as the model.getWeight. So as I said, after I create a network, it will first of all give me some random weight and bias randomly. So if I use model.getWeight here, it will give me that random value it is using, right? So you see that right now, I've not really trained it. I've not trained it. I've not done anything. I'm just using model.getWeight to get. Oh, should I zoom in again or something?
yeah. It's okay.
So I use model.getWeight, and then it will get me the weight it is using, and then it will get me the bias it is also using, right?
I said the array is 0.
Yeah, so now it means that it is using the first value here is the weight, a random weight, 1.04. That is the weight it's using. And then the next value is the bias, 0.0. So if there's nothing, it does that, right?
So please help me.
I said the first value. So now I have only two values, right? The weight and bias, only two values. This and this. The first value, if I use weight, model dot weight, it gets me all my weight and all my bias within the network. The first value, what is only to the first value is the weight. The weight value it is using for now. I've not trained it or anything, so it just gives me a random weight it will use to start with. So the random weight is 1.04. 04 something like that. Have you seen it? And then the bias value is zero point 0. But because there's nothing like it's just zero, right? And then if I want to print, let's say, I want the weight itself and then the bias itself, I can just run this next cell. And then it will give me WI, the weight is equal to 1 point, the same to 1.04, and then the bias is 0.0. It's as easy as that. So So it means that just take note that this is the initial values it is using, and then it will train and get the actual values it will now use it, it will use, right?
Okay.
So now I come and do the model.compile, and then I compile with the optimizer and then the loss. So it's going to use an optimizer of SGD, and then the loss will be mean square error, right? So I run this code, I need to compile, and then I can save my model and come and check on it later. So I just use model to save. Then after that, here, okay, now we want to see whether without even training, it will predict some value for us because you see that we have initial weight and bias, right? So if I do model.predict and I put 10 there, I want it to predict 10. It will give me a value of what? 10.41758. Right? Why is it giving me that value?
because it was
So
multiplied by
our weight was what? One point something.
1.0.
Our bias was what?
Zero.
Zero. So if you take the 10, the input 10 times that one point something plus the bias. So you see that's why it's giving us 10 point something. But the 10 point something is that's why it's giving us the 10 point something. So now our next is to train our model. So I use model.fit, then give it the x value, the y values, and then the epoch, the number of times you should train for, right? So I can just come here and click, and then it will start to train. So it will run for 500 times. It will run for 500 times. So and I'll show you something when it's done. But I think this will be fast. It's just one neuron. That's why it will be very fast. But if there are thousands of them, then you can imagine how long it will take. Sometimes it won't run on your machine. Sometimes it won't be able to run. Sometimes you have to move into the Google Colab for it to run. Right. So we have to check. So you see that it starts with epoch one. You see that epoch one is here, right?
500.
Then so it means that epoch one of 500 because we said it will change for 500 times, and then it goes to epoch two of what 500, epoch three, epoch four, and then to do that until
Get to. I think of 500 and
I think it's still running. So until it gets to what epoch
Okay, that doesn't think
500,
of 500 already.
and then it should be done. So, but we have to take notes here. We have to pay attention here. So you see that it will run epoch one, and then it will give me the loss. So you see that the loss is what 2.86. Then it goes to epoch 2, run it and give me the loss. You see that the loss has reduced. I said the aim is it will always be dropping. So it starts with a very high number because at that time it hasn't learned anything. And then it means that every time it's learning, and then it is reducing our values and stuff like that. So the loss will be coming down until it gets to a suitable amount. So we are running it for 500, for 500.
Epoch 9, I've seen like 0.9.
Which one?
The Epoch 9.
9, where is it?
Because that's the bracket.
1.0.07.
No, that's 0.9822.
You mean this one?
Yeah.
Yeah. So it's coming down. 0 point. Then it will come down. It will come down.
When you show the inner one,
Pardon?
Yeah, that's it.
So you see that you can it goes to 0.5, 0.3, going 0.07, 0.5.
there's still point that it will go up again.
It depends.
Like maybe
Probably
it
not.
will go
Probably
up
not. No,
and
no, no, yeah. Because it is learning. It has learned some values, and then it is actually restricting the values. It's making the values smaller. So you see, like we are going to 0.00, 0.0, and then we are moving to 0 times 10 to the power minus something. So it means that
I'm seeing something. Can you go up again? Let's see. I'm seeing 7.9.
now it's 9.7 times 10 to the power minus.
I'm having
So
a
0.000.
yes.
Aha.
That's minus 04.
So is it so it will go down, and there are times
So
So
this is 2.5467.
times 10 to the power minus 5.
Is
So
that E?
and
E?
exponent. So times
Exponent
10 to the power
times 10 to
point
0.05.
zero 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 five something. So you see how small the losses become. So it means that our network or our model has learned, and then the accuracy has actually improved, and it improves over time. Understood?
Yes.
So now after this, we can now inspect
But
the values generated.
before you do the inspection,
Hmm.
can this, after you've now gotten this, can it give you the percentage at which it applies?
Percentage like what?
Like whether maybe the percentage of it is like maybe 80%,
Now,
70.
that percentage is the accuracy.
Oh, sorry, that
Yeah,
is,
yeah,
you can get it.
yeah, 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 yeah.
And,
Yes, yes, yes.
okay. So
Yeah,
it's still the same as like the way you are configuring
yes,
it.
yes, yes, yes. It will be giving you every time. So it depends. It depends on how you write your code. And I'm sure you very soon. Sometimes it will give you the loss and then the accuracy.
Or
So you will see another code very soon. Right. So now after that, we can use this one to get the weight that is settled on. So now you see that our weight is settled on is 1.997 something, and then our B is 0.999. Right. So now we can now predict our value. We can now give it another the value 10. Where is it? And then it will predict it for us accurately. So we give it 10, and then it gives us 18.9. So it means that once we pass the value 10 to it, the answer is 18.9. It has predicted 18.9.
you said before you run it, you have to highlight it before you run it.
Yeah, you have to click on it.
Okay.
You have to click on it on the cell that you are running. Click on it and then
So
you
that
run.
it will run it.
Yeah. Right? Basically, that's it. And then you can plot your loss against the epoch. But this one, it won't run because my PC is not high enough. It will just kill off the kernel. Yeah, so the kernel appears to have died. So it will just, it knows how. So, any question on this?
So it looks um,
So, if you go home and you're going to try it on your own, you will be learning more stuff on it. Then just Google some stuff. If you don't understand it, you just Google it and then try to train more networks. Like there are a lot of networks available for, for you to
looks
train.
interesting, but it will then depends one on your machine you are using
Oh yeah, yeah, of course.
and due to how to configure them step by step.
Yeah, of course. Yeah. Any questions so far? If no question, then this slide two is done.